Hey everyone, so basically in today's GFG POTD we have a problem, find length of a loop. So as the problem given here, and it is a basically it's a lot of problem. So as a problem given here, given the head of a linked list, determine whether the list contains a loop. If a loop is present, return the number of nodes in the loop, otherwise return 0. So basically here we have a list of linked list and we need to determine whether the linked list is containing the loop or not. Okay, like if it is having um, loop, then we need to return the length of the loop, and if it is don't having the loop, then we need to simply return 0. Okay, so like if we are talking about the example here as it is given here, like here this is the linked list. So as you can see here, the elements like 25, 14, 19, 33, 10, 21, 39, 90, 58 and 45, and basically C is given here, and C is what? So C is the position of the node which is the next pointer of the last node of the linked list. If C is 0, there is no loop. So basically C is actually describing that this is the point from where the loop is going to start. Okay, and if C is equal to 0, that means we can say that there is no any loop is actually existing inside the loop. Okay, inside the linked list we can say that. So as the here C is actually 4, so that means on the 4 position, like 1 2 3 4. So basically from this position basically the loop is going to be started. Okay, so as you can see also from this image also, like here 25, 14, 19 and 33. So basically when C is 4, that means from 33 the loop is actually starting, and when we actually counting the length of this loop, then we can say here like 1 2 3 4 5 6 7. So basically the length of the loop is 7, so we need to simply return 7, which is our output. Okay, similarly if we're talking about the second example here, so this is a second example, and we can say here C is equal to 0. That means we don't have any loop here actually existing here, so we can simply say that this linked list is not having the loop. So there is no actual length of any loop. So we need to solve this problem with an expected time complexity of order of n and expected auxiliary space of order of 1. So basically this like problem is asked in companies like Amazon, Adobe, Qualcomm. Okay, and it is completely based on like data structures and all about list. Okay, so yeah, let's understand this problem and try to solve this problem first. So basically for solving this problem, there is actually this question is basically describing about the loop. So how we can how we can get the loop. So for getting the loop, we need to solve this problem by using 2 pointers. Okay, so here let's understand this problem. This is example 1 here. So for solving this problem, we know very well that this is our head node. Okay, this is our head node. So what is the approach to solve this problem? So basically we are going to solve this by using 2 pointer. So the first pointer is basically we can say that's slow pointer, which basically points to the head node, and second pointer which is like we can say it fast pointer, which can also be like existing on the starting node like 25, but here for a better convenience I'm like declaring it on the second position, that means on 14, which makes the problem easy. Okay, and once we have like declared it, so first of all let's try to solve it the problem first of all we have like we have created the 2 pointers. Okay, like the slow pointer and the fast pointer. So first of all we have to create it the 2 pointer. Okay, so slow pointer which basically existing on the head node, and second pointer is basically on head's next node. Okay, which is basically we can say that fast pointer, which is basically existing on head next node. Okay, now once we created this thing, now we need to do what? We need to traverse it and check whether the linked list is having the loop or not. That means we need to traverse it in that way, like slow is actually traversing the linked list by one step, whereas the fast pointers basically traversing the linked list by 2 steps, and this is sure that at some point they will meet. That means where slow pointer is actually equal to fast pointer. So this is that position. We can say that is the position where we can say that basically the loop is actually existing inside this linked list. So what we can do, we need to traverse it. So for that let's traverse inside the linked list. So while first is not equal to null and first next is not equal to null, we need to do what? We need to traverse it. First of all, I'm defining about slow pointer, so we have to define about how the slow pointer is actually traversing inside the linked list. So slow pointer is actually traversing by one step, so that means slow is next, and fast pointer is basically existing, basically traversing by two steps. So fast next, okay, like that. Now let's try to understand this problem. Basically, I'm going to describe about the first example. So as we can see here, when basically this is the slow pointer and this is the fast pointer. Yeah, so when the slow pointer is actually coming from 25 node to like 14 node, fast pointer is coming here like on 33. Okay, as we can see by the direction also. Okay, so fast pointer goes to 33. This is the fast pointer. Okay, and when slow pointer coming to 19 node, fast pointer goes to 21. Okay, so basically fast pointer goes to 21, and when a slow pointer comes to 33, then fast pointer goes to 90. Okay, and when a slow pointer goes to 10, then a fast pointer goes to 45. Okay, when a slow pointer goes to 21, then a fast pointer goes to we can say that then a fast pointer goes to 10. Okay, it goes to 10, and when a slow pointer goes to 34, that means on this position, fast pointer also goes on this position 34. So here we can say that when a fast pointer is equal to slow pointer, that means we can say that there is actually a loop forming inside the linked list. So here we can give the condition, that means we understand that here this linked list basically contains the loop. So here we give the condition like if slow pointer is equal to fast pointer, if slow is equal to fast, that means yeah, we are 100% sure that we are actually having the loop inside the linked list. So we need to do what? If slow is equal to fast, we need to take a break, and now we can simply make a count of the loop. Okay, now our second task is to count the length of the loop, which basically this question demands. Okay, so for that we are making a count variable. Initially I'm declared it with 0, and I need to do what? I need to traverse through complete linked list, and I need to count the length of the loop basically. So here I'm saying that while so before that, what I need to do, I need to define I need to declare another temp node which basically points to the slows next, as slow is already existing here. Okay, slow is already existing here, so we need to start slow by using this position, and we need to traverse it by 90 and count the length of the loop. Okay, so here we can say that slows next. Okay, so here we can simply say that while temp is not equal to slow, while temp is not equal to slow, we need to do what? We need to traverse it, like temp is equal to temps next, and we need to simply count plus plus. Okay, count plus plus. Once you have like done these things, we can simply make, or we can simply return count. Okay, which is our output. Okay, which we want to get. Okay, so once you have like done this thing, we have to also do one thing. That means here we have to give the condition if linked list is not having the loop. That means if fast is equal to null, or past next is equal to null. That in that case we can say that return 0. That means the linked list is not having any loop, so we don't have to count any length, so we need to simply return 0. Okay, and here that's all for this thing. Let's try to compile and run. Okay, so here we have to do one thing basically. So basically here I have declared the count as 0, and here actually I'm counting from this position. Okay, from 90. So that means here 1 2 3 4 5 and 6. That means we actually getting the output as 6, but we have to also count this node also. Okay, because it is starting from here and the length is not actually completed here, so we have to also count it. And here we have given the condition like if temp is not equal to slow, so we have to make +1. We have to also count that node also, so that the loop will be completed and we can simply take the length of the loop. So let's compile and run. So here its compilation is completed. Let's try to submit it. So yeah, it's submitted. So yeah, that's all for the today. Thanks for watching.